So this problem, not too bad, just a little tedious. They want us to find the equation of each line, the line and the parabola. So every time you want to find the equation of a line, that's what I tell my students, you just need a point and a slope, and then you can plug and chug into point, slope form. So points, they give you two, pick your favorites. I'll take the 428, sure, just because they're positive, I don't know. And then my slope, just do a normal y2 minus y1 over x2 minus x1. So 28 minus 10 over 4 minus a minus 5 will give me 18 over 9, so a slope of 2. And then plug and chug into here. So I've got y minus y1 equals my slope times x minus x1. So y minus 28 equals 2x minus 8. So y is 2x plus 20. So there's the equation of my line. Now I go find the equation of my parabola, and I noticed they gave me zeros of -4/3 and 2. So I can start to set up my parabola in an intercept form, because I know x plus 4/3 and x minus 2 will be factors of this. So if these are zeros, then just like -4/3, right, would make that thing 0, 2 would make that 0. So I've got a couple factors of the guy. And these will be factors no matter what constant I multiply by. I can multiply this by anything, and -4/3 would still make that 0, and 2 would still make that 0. So I just need to figure out what this constant is to lock it into place. Unfortunately, they gave me another piece of information. I know that when x is 0, y is supposed to be -16. So if I plug in a -16 for the y, when x is 0, I can solve for a. So 4/3 times -2. So I've got a -16 equals -8/3 times a. And if I just get rid of the 8/3 by multiplying by the reciprocal both sides, so multiply both sides by 3 over -8. So the -8's cancel and give me a 2. So I get 6 is the a. Cool. So I can plug that back in to my equation and clean this guy up a bit. So if I were to distribute the 6 into this one here, that'd be y equals 6x plus 6 divided by 3 is 2 times 4 is 8. And then I'm going to FOIL this with that. Notice you just give it to this one, not to both. Some people are tempted to do it to both, but it just that one. And now FOIL these guys out. We get a 6x squared minus 12x plus 8x minus 16. So y is 6x squared minus 4x minus 16. So got the equation of the parabola, got the equation of the line. They want to know where they intersect, so we've got two equations with two unknowns. We're just going to solve them, set them equal to each other, right? If y equals this and y equals that, then this must equal that. So for our intersection, we're just going to say that 2x plus 120 will equal 6x squared minus 4x minus 16. Every time you got an x squared term in it, our goal is to set it equal to 0 and to factor it. So 6x squared minus 6x, oops, that's, what did I do here? Oh, 2x plus 20, not 120. So 2x plus 20, and when I subtract the 20, I just get minus 36. There we go. Keep solving that. Divide everybody by 6. You get x squared minus x minus 6. and this factors x minus 3, x plus 2, which means that x is 3 and x is negative 2. And so if x is 3, then I can plug it into either one of those to find the y. It should be the same for both if we did this right. This one looks simpler, so if x is 3, I got 6 plus 20 is 26. And if x is negative 2, I have negative 4 plus 20 is 16. So those are my points of intersection. And now they want me to graph this thing. So I want to keep all these points and those points of intersection. Let's get rid of some of this work here. Alright, let's see what we can do with this. So the graph is kind of big. Gotta go to 28 series. Alright. So I want to go maybe by tens. So this is like 10 and 20 and 30 and 40 and 10. And 20. Alright. So for my line, all I really need are those 2 points to graph my line. So I've got negative 5 and 10 and 4 and 28. And I also know that they should both go through these points here. So I'll plot these points 3 and 26 and negative 2 and 16. So those points there were my points of intersection. My line will go through all those points. Excellent. And my parabola should go through those 2 points of intersection and these points here. So I have the points negative 4/3 and 0. So somewhere there. 2 and 0. So somewhere there. 0 and negative 16. So this awfully skinny looking parabola. Now, I don't know exactly where the vertex is yet. If I really wanted to, I could find it. It should be, you could do a little bit of x equals negative b over 2a here, because it was 6x squared minus 4x. So if you want the vertex that happens at negative b over 2a, so 4 over 2 times 6, so 4 over 12 is a third. And when x is a third, this will equal something nasty. I guess we'll find it. Okay. So it'll be 6 times 1/3 squared minus 4 times 1/3 minus 16. Just plugging in a third to that. So I'm going to get 6 times 1/9 minus 4/3 minus 16. And then I'm going to grab a common denominator. So, actually, I'll simplify that. Divide by 3 top and bottom. That's 2/3 minus 4/3. And 16 is 48/3. So 2 minus 4 is negative 2. Minus 48 is minus 50. So minus 50/3, which of course is not nice. What is that, like negative 16 and 2/3, I think? So my vertex is the x was a third, and the y is negative 16 and 2/3. So negative third, so positive third, negative 16 and 2/3, down there somewhere. And then just make it go through those 2 intersection points. And those intercepts they gave us, and that point they gave us, and you get that super skinny parabola. That's that.